Hi. Uh, the email I sent you with the file, that's a final exam from 2014, but it's the same material. I'll go over this, and I'm also going to send you another sample final exam for you to practice. So now this final exam here, in the first page where you put your name, they'll give you this table, a small table like this with a Z-star confidence interval. We'll use this in one of the questions later on, but I just wanted to point out that this would be on the first page. The first question is regression. So if you read it, they tell you we're interested in seeing if there's a relationship between the year of the Summer Olympics and the distance in inches. So you have two variables here. If you look at the table, you have year, x, and distance thrown, y, and they only give you 5 throws, A, B, C, D, E. They tell you there's more, because if you look at the graph of the regression, you'll see a lot of dots, not only 5, a lot more. So they only give you a small sample of this. So A, for example, the year was 1924 and the distance was 1817.1. Year B was 1936 and the distance 1987.4. So they gave you the year of the Olympic and the distance. And then they give you all the Minitab output for this, which would be typical to what you see. Question A. Calculate the predicted distance for observation D. If you look just right after the table, you see something called, that's in the Minitab output, the regression equation. So the regression equation is the discus distance equals, or the discus throw, I don't know. Yeah, it should say discus throw equals, the first number is minus 272, and 15.11 here. This is the equation. What they want you to do is calculate the discus throw for year of the observation D. If you go back and look at D, you'll see that the year is 1948. So all you need to do is plug 1948. So discus throw equals 27272 plus 15.11, and the year, you replace this by 1948. If you do this, you'll get this number, 2162.28. And they should tell you in the Minitab what the distance, the unit measurement is in inches. So this inches. Okay, so we calculated this. Calculate the value of the residual. B, calculate the value of the residual. Residual is always y actual minus y predicted. The actual would be what you see in the table. So if you look at the table, for year 1948, what was the distance? It was 2073. So the one from the table, the 2073, is the actual one. You minus it from the predicted. The predicted is whatever we got from plugging the number into the equation. The equation gives you the predicted. So it would be the table, the actual number, minus the predicted, the one from the equation. You minus these two, and this would be negative 8428. Now, question C, on the plot, circle the observation D and indicate the residual. Now, the graph itself is not very clear from when the person scanned this panel of sample exam. So basically, you know that observation D is year 1948, and distance, the actual distance is 2073. So you look here for the year 1948. So you look in the x-axis, you look for 1948, and here you look for 2073. So there is a point that's common between them, and this point you just circle. That's why if you look at the one I sent you, there is a circle in the middle, and they say it's for part C. So this observation is here, and the residual would be just the distance between the vertical distance between the line and the point. This distance here is residual. Okay. Before we get into the next one, this is the ABC. Before we get into the next one, I'll throw an extra idea they might ask you. So I'm going to keep the equation for now. They might ask you what point or which observation has highest positive residual. Or the one that has highest negative residual. If they ask for the highest positive residual, you look at the line, we look at the dots above the line, and you pick the one the farthest from the line. So the one farthest, but on top of the line. Top of the line, and the farthest would be the one with the highest positive. Highest negative would be a point below the line, and it's the farthest from the line down. That would be the one, so you highlight it. So there might be a question like this in the final exam. And question C. Now, if you remember, this is the equation from the actual Excel Minitab, sorry. This equation has two numbers, a number by itself and a number next to a certain label, year or whatever. The number that by itself is B0, and B0 is the y-intercept. The number next to this is your slope. So in question D, what's the interpretation of the value of the slope? First of all, you need to know slope could be positive or negative. In this case, your slope is positive. The meaning of the slope is standard. You need to say the predicted value of y increases by slope for every 1 unit of x. This is the standard way of explaining what a slope is. But instead of y, so it said the predicted value of y. Instead of y would be whatever the equation is. It's for the discus throw. So the expected value of discus throw increases since slope is positive. And if it was negative, you would say decreases. So again, the predicted value, only the ones where I have a line under, change according to the question. So y would be the main thing in the equation. So the predicted value of discus throw increases because the slope is positive by, and you put the value of the slope for every 1 unit of x. And we know x is year. And instead of unit, you could say for every 1 year or whatever, or 1 unit, doesn't matter. This was a multiple choice, and if you see the answer A, predicted distance increases by 15.11 for every 1 year. So, yeah, you put the unit measurement with this, inches. Question E. A sport fan is interested in predicting the discus thrown distance for the gold medal winner in the next Olympic 216. Can you do this? Remember when we did it for the observation D, and we say it's 1948? And anytime they tell you predict or calculate, that means you need to plug it in the function. So can you plug 216 here and get the discus throw? No. Why we can't do it for 216? Because if you look at the graph or the table, the maximum year is 1960. So max year, 1960. 216 or is over. This equation is only good for the region within. Within means from the minimum year provided to the maximum year provided. Anything outside this range, this equation is no good. We consider it unreliable. So the answer, and this is a typical question, they will give you a number that's either too much high or too much low compared to the other points. All you need to say is, no, we cannot do it, it's outside range. And the answer, if you see, unreliable, this here is well outside the range of the above data. I'm gonna in F, calculate the correlation coefficient. And yeah, someone answered this, I don't know if it was a TA or a prof. 90% of the answers provided on the actual exam are right, but there are some mistakes in some areas. This is one of them. The question here says, calculate the correlation factor. So we're calculating correlation. Correlation is R. And you say R equals minus plus square root of your R squared. So it's minus plus square root of R squared. And if you go to the actual file, to the mini tab, the beginning of the actual exam, you'll see right after the equation, they give you R squared of being 96.5. So this here, R squared, was given at 96.5%. So you square root it, put plus minus, and you square root of 965. So 965, and you square root it. It gives you 9823. plus minus 9823, and then you say R is, you take the positive, and you say since slope is positive. Because we know that the slope is positive, then the correlation must also be positive. But you have to indicate plus minus first, and then pick the sign that goes with the slope, in this case positive. So that's how you do the correlation factor. What else I can add to this? Sometimes you have to make sure, are they asking for correlation or something else? Like, for example, they could say calculate the determination factor. It's called determination or variation. In this case, if they ask for variation or determination, then R will be given. R will be given 9823. So your determination or variation, that's another name for R squared. So in your exam, R squared was given, and we had to do the calculation to calculate the correlation R. In other exams, they might give you the R and ask for this. In this case, you just square this. And that will give you 965 or 96.5%. Also, they might ask you to explain what R squared is, the determination of variation. So they might ask you to explain what this means. Again, the meaning of this is standard. Few words you need to change, so I'll tell you what you need to say. You put the percentage and you say of the variations of Y can be explained by X in the regression line. So you put the percentage, if they ask you for the R squared, you put the percentage, variation of Y was the discus throw, and X was, so Y was the discus throw, X was year, and the regression. So what Y is, what X is, and what percentage is, that's the only thing that you change. Everything is the same. And if 96.5 can be explained, 3.5%, which was what's left, cannot be explained. I think this covers everything you need to know for regression, which is the first question. So we go to question 2. Question 2, according to the National Health of Nutrition Examination in the U.S., mean height of a 10-year-old girl is 56, standard deviation 2.7. So let's call X girls, or 10-year-old girls. You're given their average height, mu, and you're given the standard deviation of their height, X. Mu, 56 inches, and X and sigma was given at 2.7. And then Y would be boys 10-year-old. They give you mu and sigma. Mu is 55 and sigma is 3.8. And the question is A. Find the expected difference or mean of difference and the standard deviation of difference. So you need mu for difference and you need sigma for difference. So mu for difference, and they tell you in the question they want it between Anna and Fred. So they want you to start girls, boys. For the mu of difference, you need the first mu minus the second mu. So it would be 56 minus 55, 1. So it's very straightforward. So mu difference, you just minus them. Sigma difference is different. You take the first sigma, standard deviation squared, plus the second one squared. So 2.7 squared, 3.8 squared. I think here they did the mathematical mistake, so I'm gonna give you the right number. Let me just do it quickly in my calculator. So 2.7 plus 3.8 squared $4.6615. So the answer for this is 4.6615. They have it at 5 point because they plus 4.8 instead of 3.8. But this is how you do the expected. The expected could also be you're asked for the difference extra. They might ask you for the total. What's the mu of the total and what's the standard deviation of the total? If they ask for mu total, instead of minusing them, you add them. If they ask for the sigma, sigma is always this. You always square them under the square root. So regardless, if it was difference or if it was total, sigma is always done independently. Has nothing to do with the question. Sigma is always for difference and for total the same. Okay. So we have the sigma for difference, so I'll add them here. Mu difference is 1, sigma for difference is 4.6615. Question B. The assumption that Anna and Fred's height are independent. The fact that I told you when you do the sigma, whether for difference or for total, is the same. Why? Because they're independent. So the fact that they're independent helps us to calculate the standard deviation. So the answer is needed to calculate the standard deviation. So independent assumption needed to calculate the standard deviation. That's why it doesn't matter if it's difference or total, it's always the same. Now, question C. Calculate the probability that Anna is taller than Fred. So we need probability that Y, because, Anna is X, that X is taller than Y. Meaning that X minus Y is more than 0 if I bring it over. Instead of X, Y minus, we can say the difference between them is more than 0. So the question is based on the difference being more than 0. So we go we draw the z table. The middle, or the line in the middle that divides this into two equal halves, would be whatever the mu of d is, and in this case 1, at the z line 0. You're looking for the area more than 0. If the middle point is 1, 0 would be somewhere here, less than 1. And you're looking for more, so you're going to shade the more. In order to do the probability, we have to put everything in the equation z difference. The equation z difference is d minus mu d over sigma d. D being the 0, mu d being the 1, and sigma d being these 46115. So I do this in my calculator. So 1 divided by 4.6615. This would be negative to 1 rounded to 2 decimal places. So now I know that d more than 0 is equivalent to z more than this number. Now, the last page of your exam is the z table. So if you go to the last page, now when you do probability z tables, if you're looking for probability z more than a number, it's 1 minus the table. If you're looking for a probability z less than a number, the answer would be the table. If you're looking for probability between a large number and a small number, you find the large from the table minus the small from the table. In your case, it's z more, as case number 1. So right away you go 1 minus, and all you need to do is to figure this out from the z table. What you need to do, you go to the negative one, you go to the first 2 digits, negative 0.2. So the first digit after the decimal place 2. And in this line, the second digit must be all 1. So you need the number where the first digit is here, negative 0.2. The second decimal place is 1. And this number common between them, if you do it right, actually it's more down. And that would be 4168. So this number, 4168. So your 1 minus 4168, the answer is 5832, or 58.32%. So you go back to the actual question. Okay, and I told you there are some mathematical mistakes in the calculation they've done, so stick to my answers. Mine is a bit because they got some wrong calculations, so stick to the answers I give you. What additional assumptions? Anytime they ask for additional assumptions, say x and y must be randomly selected and normally distributed. And the fact that's normally distributed is more important. So they're normally distributed, and throw that they're also normally distributed and randomly selected. One other thing before we go to the next question. In some instances, this is a straightforward question. In some instances, you know, from the beginning of the question, where they give you the mu and the standard deviation for girls and then for boys, they could give you mu, they always have to give you mu, but instead of standard deviation, they might tell you, and the variance for girls, 100. So they didn't give you this, they give you the variance. So when you're given the variance, you can get this by square rooting this, and you get your standard. So if you give you the variance, make sure you square root it first to get the sigma. But other than that, it's a straightforward question. I'm gonna stop here. That would be part 1, and then we'll continue in part 2.